So something a little different for the channel today. A repair video, at least. I think so. I bought this Spectrum as untested, which usually means broken. Let's see if it works or if it goes bang. Roll titles. Is that it? So the first thing I'm going to do is, before I power this up, is I'm going to check the power supply. So we've got the original ZX power supply. Now, I am not going to plug this in to the wall socket and plug this into the computer. It goes into the back here. Where is it? 9 volts DC. Because we don't know what the state of this power supply is, whether it's giving out the right voltage. Could be giving out something horrendous and we're going to blow this before we even start. As I said, this was sold as untested, and a lot of times in the past on eBay and stuff, when people told you they were untested, it's because they knew they were really broken. But these days, with the trouble of getting these to connect to a modern TV, it's actually, you know, a lot of the time they are generally untested and they could well work. And it could be that this power supply is duff now and we'll end up breaking it. So we'll not do that. But what I did notice when I had a quick look at this power supply is this is obviously a British 3-pin plug, and it should be wired a little better than this. First of all, you can see it's a really old plug. British plugs now, this is the earth pin for a British plug. They should have a black plastic surround, not on the earth pin, sorry, on the live and neutral pins here. But they don't. So they're not, this plug is not passing the current British standard for these, for 3-pin plugs. Because this was back in the 1980s, this is what they're like. Now, I think I do have a spare plug somewhere. I'm pretty sure I know where it is, but it's very buried. So for now, I'm going to play a little bit dangerous and I'm going to use this plug. However, it shouldn't have wires just flapping in the breeze there as well. You can tell this was back in the day of the 80s when you would be supplied with every electrical appliance, and generally it just didn't come with a plug. You had to buy and supply your own plug and wire it up. And the Spectrum was obviously definitely to save money. Sinclair would definitely not put a molded plug on there. You had to wire your own, and this has been done very poorly. There's a little white ring there you can see, and that's a cable clamp, and that should be clamping onto the outer of this flex and not the wires themselves. That's a strain relief basically. So I'm just going to get some tools, and I'll quick open it up and just see how bad it is inside, and then I'll redo it and rewire it before I use it. So let's have a quick look inside. Just got a few basic tools. So these two, if you're not familiar with the British plug, these are the ones that secure that cord grip. So the one you need to undo is this centre one to get the actual lid, cap, whatever, of the plug off. And yeah, things we shouldn't be seeing in here. I mean, if you've wired it correctly, the brown wire in the UK, at least back then, still is connected to the live correctly via this internal fuse. And the neutral is connected to the neutral pin here, which is quite correct. We've got an N for neutral there. However, if you're wiring these correctly and safely and properly, you shouldn't be seeing any. This is how I was taught a long time ago. My instructor, you shouldn't be seeing any bare wire there. That should be just neatly to the plastic. The plastic should be going right flush almost to there. Not too bad a job on the live. Yeah, they've done that okay as it happens. That looks fine, as long as they haven't secured on the plastic there with this screw. The fuse, I can tell, it's brown, which means it's 13 amp fuse, and that is incorrect. Obviously, again, it's all UK plugs, but the rating for this Sinclair, you won't be able to pick it up on camera, I don't think. It's very, very tiny rating. It's 1.4 amps. So what you do, you pick a fuse, it's a little bit above the maximum power this is going to draw. So the lowest fuse that we do in the UK generally, you can commonly buy, is 3 amps. This should have a 3 amp fuse in, but it's not. It's got a big old 13 amp fuse. You can probably just see maybe the 13 there, just there sort of thing. So I do have some 3 amp fuse, so I will do a good job in a sense. I'll put a 3 amp fuse in there and I'll rewire that. I can't do anything about the plug. I do need to get the new plug on, and I will do that sometime in the future. But for now, we'll have a bit speedy up montage of me rewiring this plug. So I've got my multimeter ready. This is an old, cheap multimeter. I do have a much nicer auto ranging one, but this is the first digital multimeter I ever got. I think I got it from Maplins. It looks like I did, probably. It's the M215, the M story stands for Maplin. Precision Gold, I'm sure that was one of their cheap mates. But it's cheap, and it is cheap, and it's absolutely donkey's years old now. And for the job we're doing, the cheapest multimeter you can pick up for $3, $4, $5 or pounds or euros, whatever we're paying, is fine for this sort of work. So anyway, I'm going to just go off camera because my plug is just around the side, it's just around the back there. I'm going to plug it in, I'm going to see whether it goes pop or bang, makes like magic smoke, whether any of the capacitors fail and make a horrible smell. Let's find out. I'm going to go and plug it in. So obviously, going over here, let's plug it in and hope that nothing goes pop or bang. Well, it's in. I sort of thought I heard a slight click, not entirely sure. But, well, do I feel it humming or anything? Sometimes you can with these old ones. Right, so on the Specky, which it wounds a lot of people, but on the Specky, I believe they are centre negative, outer positive. Pretty sure that's the way it is. So let's plug in the negative on there, set to 20 volt range. The output's supposed to be around, according to here, 9 volts out. I do know that this is an unregulated power supply, so we're going to get, with no load, we're going to get a few volts higher than that, 2 or 3 or something like that. So let's have a look. I don't know whether that's in, that look better for the camera. Double check whether that looks okay. Yeah, you can see that okay, can't you? So let's press that on. A little light, 13.8, but it's unloaded, so yeah, I think that's probably going to be fine. So yeah, we're working okay, and it is, as we can see there, it is actually definitely centre negative. Something to bear in mind if you ever buy a replacement power supply for these. Okay, so that's working. The next job is to plug it in. Now, the Specky, when it starts up, oh, get over there. The Specky, when it starts up, doesn't even do a beep. It does have a small piezo speaker beeper. It's not piezo, is it? Actually, it's a proper tiny little speaker, I think. I'll have to check when I open it up, I can't remember. Although it has a speaker, it won't make out a startup sound. So the only way we're going to know whether it's actually running is because there's no LED lights, or there's absolutely nothing. We're going to have to plug it into this TV and see if we can tune it in. We can do a composite mod on this, which I will be doing in another episode, perhaps, or maybe even this episode, if this just works for time, because otherwise it's not going to be a lot to do. If this doesn't turn out to be a repair video, it'll be a sort of upgrading, refurbing video, changing caps and things like that. Okay, it should be channel 36, I believe, the Specky. I was reading a small manual that came with this, and it said it would be channel 36. So again, I'll speed this up. And there we go, channel 36. We have found it, so we can press stop on that. There is something coming out, it's picked up on something. So we will set that to yes. And I presume it's going to switch to it. Although I didn't, but okay, let's come out of that. Weak or no signal, do I need to press 1 for channel 1? Yeah. Okay, there's something there, we'll just mute the sound. There is definitely something happening. Now, we might need to do a bit of fine tuning. You can see there's definitely some other white screen I'm expecting. It could be just this TV really struggling to pick it up, but we've definitely got some sort of, something's happening, it's not completely dead. Right, thing we can do is we can do a composite mod on this. It's very, very simple. So we'll definitely get some sort of guaranteed picture. I don't have an old TV I can test with, so it's kind of this or nothing. So I'll open it up, I'll quickly check the voltages that are coming out, the voltage regulator in this, and then, whoa, it's whizzing around there, it's really trying. And we'll go from there. Okay, let's get things unplugged. Out of the way. Right, so let's have a look. Said this is almost, I don't think this has ever been taken apart. I mean, it looks like it's hardly ever been used. Let's just whack out these screws with an inappropriate screwdriver because they're crossheads, and this is not Phillips screws perhaps, whatever, but this is not one of those, just a flathead, but it fits. So we will do that. So I think I've ever got so far 3 screws. So that there's just 5. All feet, have you noticed, all intact and not worn or anything. So yeah, it's definitely a nice sort of mint spectrum. So I'm not expecting anybody to have been in here before. I'm not expecting any surprises. Now we have to be careful. Although this is quite mint, these ribbon cables are very fragile. Back in the day they were very fragile, let alone now after all these years. So yeah, we've got to be very careful these connect to the room cord. I can see they're already coming apart there. So it's just ever so, and there it's broken. So the keyboard has gone. Yeah, oh, there was a lot I could do about that. So the keyboard is kaput already. That one's come out okay, but that one we couldn't save, which is a little bit annoying, but there's nothing I could do about that. It's absolutely knackered is the word for these when they get old. So that's a little bit annoying. So it needs a new keyboard membrane, which you can buy. I've seen them. So yeah, which is a bit of a pain because you've got to take the this top bit off with all the pin types on, and when having it has to come out and when having to replace that. But yeah, it's mendable, it's doable. It's frustrating now. However, I think the Spectrum will boot up without the keyboard being connected, so that's not too much of a biggie for where I want to go for now. So let's power up, check some voltages, just the basics for now. So let's get a ground on there. This is our 5 volt regulator coming in. The first pin is the voltage going in, so what was it, 13 point something or other, 0.8 maybe when it was unloaded. Let's see what's going in now that we've got power on. 11.3, you'd want it near 9 volts really to stop excessive heating on this component here, but you know, it's fine. Middle pin, can't remember if it's ground or it's the 5 volt output, we'll find out. So that's obviously ground, and this should be about 5 volts on the output. 5.05, yeah, it's really quite bang on really. Then we have some circuitry here which actually generates 12 volts because these memory chips here, which is the lower 16K bank, so if you bought a 16K Spectrum, you'd get all these and there'd be nothing here. If you bought a 48K Spectrum, you'd get this 16K and then you get an additional 32K here with these. So these ones are a bit more exotic though. These require plus 5 volts, minus 5 volts and 12 volts. Whereas these just need your normal 5 volts and 0 volts. So we need to check the voltage on this, make sure it's okay. So we'll get us ground back again. The first pin up here is the minus 5 volts. So pin 1, minus 5 volts. So yeah, near enough, that's fine. Plus 5 volts is this bottom pin down here. Yeah, that's hunky dory. And the plus 12 volts is the bottom pin here, which I think is pin 9. 1, 2, 3, 4, 5, 6, 7. No, pin 8, sorry, my mistake. 16 pin chips. 12.19, 12.2, it's 10 on the high side. It's probably just about within spec. Things are probably going to be running a little bit warm at that sort of voltages. But yeah, apart from that, though, everything looks like it's in spec. It looks like this Spectrum is probably, fingers crossed, working. We couldn't quite see on the TV screen because we need to get the composite out of it. So one of the first things we need to do is to remove the circuit board from this Spectrum case itself. It's just held in on this issue 3 anyway with just a single screw there in the middle. So we'll just take that out and put that with one of the screws for the case. And then the circuit board should just pop out. There we go, simple as that. A bit of dust in there, out of the way. So I'll just need to refocus the camera. 1 second. What we're going to do is, well, this is the composite signal coming in. So this goes off on a trace here, basically going back to the ULA chip via some of the circuitry here to create the composite signal. But the composite signal goes into the modulator, which then turns it into an RF signal, which the old TVs could understand. So we need to intercept that. We need to take that composite mod. We need to take that composite connection out. This is the power for the modulator. So we're going to desolder that and disconnect this modulator from both the composite signal and the plus 5 volts. Okay, so let's take the plus 5 volt connection off first. So one thing you can do, even with simple joints like this, is add a little bit of solder. It can make it easy, it can help the heat to conduct around and into the joint. And this big old modulator is, there we go. So I've got some in, I'll leave that heating, and then hopefully this will just gently pull out. There we go, that's the one away. A little bit messy there, I'll probably just get to smooth that out there. Could even just suck that up with a solder sucker if you wanted to. And the next one, well, on this one, I think that we might want to turn it over. There's not much solder on the top of the board, all the connection is underneath. So I'm just going to put my pliers just gently on that cable there, and then just heat up from this end. Probably won't need any additional solder because it's only that, it's bubbling away nicely, and we'll just pull that out, and out it comes there. So we've got both connections removed. Let's take the can off, put the iron away, watch out, catch my hands on it. These should just pop up with a bit of persuasion. Where's my screwdriver? Just to try and just wheedle my way under that can. I might just change my other camera handle. It might be better than trying to work here, but just give it a go for a second. I'm just trying to splay those out. No, I have to change with the camera handles, at least you can see, and I can move my actual hands a lot easier. So all you want to do is just pop this off. I just couldn't get in with the angles where I had to have the camera before. It's very hard when you're trying to film and do things. So I'm just gently just rising that off, and off it pops easy when you've got the right angle. So I'll just put that to one side, and we'll refocus the camera. 1 second. So what we want to do, we've disconnected this. This was the composite signal in. This was a 5 volts, so we'll just tuck that out of the way there. We'll tuck that out of the way. We don't want that to connect to 5 volts, do we? So we'll just tuck that away. We want to disconnect this resistor here off the RF out, and then what we're going to do is connect up the composite signal from its connection there to the RF out there. So let's just disconnect that resistor. Add a little bit of heat in there. And it's bubbling. And we'll just gently pull that out. And a little bit broke off. Is that just a solder? That's just a solder. So we've now disconnected that resistor. So that resistor, if we wanted to reverse this mod, could just be soldered back on there. We could solder the power back down there and the composite back down there, and we could reverse this mod really easy. The next thing we need to do is to, where we put it, we've got to put in this capacitor. So we've got to connect the composite signal to here via this capacitor. This is a 100 microfarad 10 volt capacitor. The negative, indicated by the negative on the casing here, connects to the RC jack, and that's also the short lead. The positive connects onto the old RF signal just there. Now this is a little bit tricky to do, to get to look neat and bent into the right places, but we'll give it a go. And we'll push it through. Perfect. and that's not too bad. It is a little bit fiddly, but we're all done. Let's give that a test. Okay, moment of truth. Let's put the composite cable into my RF, which is now a composite out, and we'll put the power on. Now, you remember when we did the quick check trying to tune it into the RF signal, we did sort of see like a bit of a white of something happening when it was trying to tune into it. Now that's a good sign that this is fully working, which is not actually what we want. We want to do a bit of a repair video. I'm suspecting this is going to work fine because a Spectrum, when it boots up, has a white background. So we'll see. We'll plug it in and find out anyway. Let's plug it in. And yeah, as I unfortunately suspected, yeah, it's absolutely fine. We've got it working perfect. Or is it? In the next episode, we will go through some further checks and we will be checking the RAM. Now this RAM here, these 8 chips here, are the first 16K of memory. Now that provides the video RAM and also the first start of program memory. This bank of 8 chips here is the additional 32K RAM, which you got if you bought a 48K machine. If you had a 16K machine, you just got this, and these were unpopulated. A few logic ICs, I think, were unpopulated. I'm not a Spectrum expert by any means whatsoever. So we do need to do some diagnostics, make sure that the 48K is working, that the 16K is definitely all fully working, all proper. And we'll go into that in the next episode. So you may be wondering, with this composite mod, I might just unplug it now. You can see that's working fine. We put on this capacitor, didn't we? This, whatever it was. What was it? How many microfarads? I forget now. 100 microfarads and about 10 volts or something like that. Why did we do that? We had the composite signal coming out of that connection just there where the electrolytic is coming in on the positive, and the negative of the electrolytic went to the RF connection, to this connection. Why didn't we just connect that straight to that? Well, you could do. However, some TVs will not be happy with that. Why that is, well, we'll show you. I'll get the scope out and we'll scope what the signal looks like there on this side of the capacitor before it goes through the capacitor, and we'll scope what it looks like afterwards and see what the differences are and how that might affect some but not all TVs. Let's get the scope. So we've got our Spectrum powered up, we've got our oscilloscope ready. Let's have a look. We'll connect the probe up. So first thing we're going to do, we're going to have a look at the output of the composite. So remember, we have our composite from the spec is basically ULA and via some circuitry here as well, a little modulator thing there to generate the composite signal. We're going to measure that signal and also the signal that comes out of this capacitor. So the composite signal goes into this capacitor, we'll measure it before, and it comes out and then goes directly to the composite output now. So we're going to measure it on the output of the capacitor and on the input of the capacitor. So let's just get a nice grind off that can and pop that on there, and we've got a beautiful composite signal there. You see it's repeating nicely over and over again. If we look here, we've got a minimum voltage of about 500 millivolts, minus 500 millivolts thereabouts, and we've got a max of around about 160 millivolts thereabouts ish. What is it? What is the signal before it goes in? So that's the signal that's good, and we can see it works on the screen. What is it beforehand? So let's just take that off there, pop it on the positive of the capacitor, which is the input to the capacitor, the composite from the specky, and like, where's our trace gone? Well, if you look carefully, the yellow line is right up there now, so we need to bring that back into view a little bit, bring that down. So something's happened. Just I'll try trigger. Let's bring the trigger up, and there we go. Let's get a stable display trace. If you look now, the minimum voltage is 2.38 volts or thereabouts, with a maximum around about 3 volts. We've basically got a 2.5 volt, thereabouts, 2 volt DC offset to that wave. It's been shifted up. Now, some TVs, I'll be fine with that, not a problem. But by all accounts, I mean mine, as you can see, by all accounts, well, sorry, mine is okay, but it's getting the good signal through the capacitor. But some TVs will not like it with that DC offset, and some will be fine. So just to play safe, put the capacitor in so that any will be okay. There's another thing you can do on these mods, which I've not done. There's a couple of transistors you can get replaced if you think your display is a little bit dim. So if you want to brighten up the displays, a couple of transistors you can replace. Most people tend not to replace them. I think this screen might look a little dim, but it's also, I think, perfectly acceptable. And I could even turn the brightness up on the TV if I wanted to. So I'm more than happy with that. And fiddling around replacing transistors when you don't really need to, nah, not going to happen. So the next thing we're going to do then, we'll explain that, is we're going to replace, let's just unplug, take the power off so I'm not actually accidentally catching things on the board or this, that and the other. And take that off as well. We're going to replace the capacitors. Now, they all look reasonably okay, but they are incredibly old capacitors now. You should replace them with good quality capacitors, which I have bought, and they're even the same colour as these that are on the board, so it looks all aesthetically correct. But the capacitors, particularly these ones here, are part of the voltage conversion circuit. So we get that sort of like 10, 11 volts going in, don't we? And we get 5 volts out of our regulator here. But if you remember, this memory needs plus 5 volts, minus 5 volts, and 12 volts. You know what I mean? Really pain in the arse memory. So how do we get the minus 5 and the plus 12 from just our 5 volts coming out of the regulator? Well, we have this sort of like little boosting circuit and things going on here. And so, remember, we measured 12.2 volts, which I thought would be high. Now, I'm no expert on speccers by any shake of anything. Whatever you want to shake, I'm not an expert at it. I'm not an expert on speccers at all. But, you know, it should be 12 volts, 12.2 and a bit, whatever it was. It seemed a little bit high to me. So, replacing these may bring us more into spec. Certainly, if we leave them, at some point they're going to fail. The voltage will go wrong. It'll destroy these chips. So just, nah, you don't want to go there. Now, I was looking, and I'll bring this up to the camera in a minute, we'll get a refocus on it. When I was quickly doing a visual check, we have this capacitor here, doesn't look very good. Now, I'll give you a close-up on screen now. But basically, you can see that there's like a bulging bit at the end there. Now, electrolytics, when they're failing or failed, bulge. Sometimes at the top of the cans, whatever. I mean, this looks like it's kind of like a bit of an extra solder bob, or part of the connections being pushed out. But yeah, that definitely looks suspect. So maybe when we replace these, we'll get that voltage more into spec. So I'm not going to insult you by doing any sort of like speed up footage of me replacing all these capacitors. All I'm going to do is, like I did before with the other mod, I'm going to put a little extra blob of solder on where the capacitors are. For example, that's those two there. Extra blob of solder sucker on, suck them out, make sure they're all nice and loose so I'm not lifting traces. Remove the old capacitors and put the new ones in. And I'll replace them probably, like for these I'd replace in a pair because they're both facing the same way. And I'd just replace that pair, do that. Do one at a time. Don't take them all out and then put them all back in, because you may cock up and put them in the wrong way around. Because, this is an issue 3B board. As I said, I'm not an expert on spectrums. I think the silk screen on this is correct, but on issue 2 boards, or at least some issue 2 boards, maybe even other boards, but definitely issue 2s, there are some of the silk screen where it says, look, positive there, goes that side, but they're actually wrong. They've got it wrong on the silk screen. So we know this spectrum works, so I'm going to take a capacitor out at a time, put the new one in, and then move on until I've done them all. So I'll get on with that, and we'll come back when I've done it all. So here we are, all recapped, all double and triple checked for correct value and orientation. So there shouldn't be any cock-ups. Let's plug it in and find out. We'll just switch to a different camera angle. So composite in, power on, fingers crossed, as if we needed to. Fantastic. Picture looks really good now, actually. I mean, it looked pretty good before, but we've changed the caps, and that, to me, probably not picking up on camera, that is a really crisp image. So, I'm aware this video is already going on for about 30 minutes or more, so I want to split the rest of the work into a further episode. What we're going to do in the next episode of restoring this Spectrum is we're going to change this voltage regulator here, this 7805, for a modern switching unit, which is a pin-for-pin replacement we can pop in, because this runs really hot, as you can tell, because it's big arse heat sink on here, whereas the modern switching unit runs really cool. The way that will help is not necessarily for the 7805, I mean, probably will a little bit, but more for this ULA. The ULA, as in most retro computers, the ULA is just about the hardest thing to replace, replicate, whatever. The Z80 and the 6502s are easily obtainable. We can cope with that. But ULAs in any sort of retro computer are hard, and they usually do run a bit warm, and this one on the Spectrum is no exception. So this running warm, plus the heatsink dumping all this warmth into the board as well, in that small compact case where everything's packed in with not a lot of ventilation, is not helping that one to have a long life. So by replacing this with a modern cool running unit, we'll reduce the temperature inside the case, which will reduce the temperature of this unit. So we'll do that and get that out of the way. We'll also finish off, I've got a new keyboard membrane that has arrived. We'll fit that in, so we've got a working keyboard. I've got a diagnostic cartridge that I've ordered, and that has arrived as well, that we've got to assemble it myself first. So I'll do an episode on assembling diagnostic cartridge, but when I have, I'll just plug it out, switch it off. But when I have, that will plug into the, you can't say a cartridge port really, can you? It's just the expansion slot on the Spectrum, which is just an edge connector there. So I'll plug the diagnostic cartridge onto the edge connector after I've assembled it in another video, and that will do a lot of tests on the memory, you know, for the 16K and the 48K and various other tests as well. It will do, so that will do a good job of doing a lot of the work for us in trying to make sure that this Spectrum is working tickety-boo. When that's passed all the tests, I'm going to actually finally test the cassette port, which is just here at the back. Let's just take the video cable out. Got cassette a connection for saving data to a cassette and a connection for reading in. So we'll obviously read in a game and play a game, make sure that's working, and we'll also try and save a program to cassette and read it back in. And then when that's all working okay, we'll call this Spectrum done. So that's it for now. So this has been quite a different episode. It's the first time I've ever done a retro computer. I plan to do a few more in the future. I do enjoy them. As you know, I've been doing my 6502 series, which I will be coming back to. Don't worry, that's not been forgotten about us or anything or stopped. I just have a little break from it and doing a couple of Spectrums or so, and then we'll get back into that as well. So that's it for now. Thank you all very much for watching. Thank you for people that support me in various ways, and there's links down below for those various ways that people do. If you do support me on Patreon, you get an ad-free experience and you get the videos obviously uploaded first. But that's about it, yeah. Thanks again very much for watching. Take care. Till next time.